Hi guys, this is Chapter 12, Lesson 4 on the shape of data distribution. So remember what you're going to need to have every time: pencil, a pen, and your book out and open, starting on pages 891 through 894. So we're going to go ahead and start with the vocabulary startup. So this is in the middle of the first page. So what we're going to do is we're going to go ahead and draw lines that pair up the words with their definitions. So the first one is a cluster, and what that is, it's data that is grouped closely together. A gap, that would be numbers that have no data value. Symmetry, I skipped peak there. Symmetry is the left side of the distribution looks like the right side, so that means both sides are equal looking, they're symmetric. And then, of course, peak is the most frequently occurring values or mode. All right, so on this one here, the line plot shows the cost in dollars of parasailing for different companies on a certain beach. So number one asks you to draw a vertical line through the middle of the data, and then it says, well, what do you notice? So let's go ahead and draw a vertical line through the middle of our data. So hopefully what you notice is that both sides are exactly the same. This is what symmetric means. So we notice that both sides look the same. And number two says, use one of the words shown above to write a sentence about the data. You could use the word symmetric, you could use the word peak, cluster, or gap. So there obviously are no gaps, which would be spaces in data. I went ahead and just used the word gap. There are no gaps in the data. Now you could have used symmetric, saying that both sides are the same, so therefore they are symmetric. It doesn't really matter, but they just wanted you to use just one of the four words that they put earlier above. All right, so let's go ahead and look at the next page. So on this one here, we're going to look at the line plot that is to the right of these words. It says here that data that is evenly distributed between the left side and the right side have symmetric distribution. Now the example that you see over here, this is not symmetric distribution. If it was, then you would see the same exact things on both sides if you were to split it down the middle. So you notice that on the left side here we have a dot or an X at the 8, and then 3 X's at the 10. If this was symmetric, then we would have 3 X's at the 12, and then of course the 1 dot at the 14. So it's not exactly symmetric. But the previous example, this one over here, is considered symmetric. The distribution shown has a cluster of several data values within the interval 10 and 12. So a cluster is where you've got a lot of your data kind of close together. So go ahead and label that. The gaps would be at 9 and 13 because they have no data value. There's no numbers there, so it basically leaves a gap or a space. And then, of course, the peak would be the high part. So look at the one that has the most, and that would be the 10, and that is considered the peak, which also happens to be our mode. All right. So let's go ahead and look at our next part here, example 1. Now what the main part of this lesson is for us to look at tables, line plots, stem and leaf plots, and we're going to do more describing of the way that our numbers or the data is distributed. That means how it's basically spread out. So if you look at this first example here at the line plot, you'll notice first of all that there it is not symmetric because both sides are not the same. So you'll notice that there's more X's on the right-hand side of the graph than there are on the left-hand side of the graph. So when you're describing the shape of distribution, you want to use those 4 vocabulary words that we talked about at the front screen, which was clusters, gaps, peaks, and outliers, and symmetry. I'm sorry, we didn't bring up outliers at the beginning, but outliers is something that we do want to talk about because it keeps showing up. So you definitely want to think about those 5 words: clusters, gaps, peaks, outliers, and symmetry. So what I like to do when I'm describing a data set or the distribution of a data set, I ask myself, is it symmetric? Why or why not? So if it is symmetric, I'm going to tell why it is, and that would basically mean that both sides of your data is the same looking. If it's not symmetric, then you would basically tell me the left side does not look like the right side. So if you look at this one here, it basically tells you the shape of the distribution is not symmetric because the left side of the data does not look like the right side of the data. You simply would state exactly what I had said, and they've got that information for you right here as well. So then go through all the rest of the words and tell me about if there are clusters, gaps, peaks, or outliers. So you can see here that there is a cluster. So there is a small cluster. Oops, let me get my marker ready. There is a small cluster over here in this area between 16 and 18, and then there's a larger cluster over here between 22 and 25. So you could talk about that, and it does tell you this right over here. And then you can also tell me that there's gaps. So there's gaps between 19, 20, and 21. And then you could also tell me that what the peak is. Remember, the peak is like the highest part, and it peaks at the 22. So really, it's pretty basic. You're just having to go through each of those vocabulary words. In this example, there are no outliers. Remember, an outlier is a number that kind of sticks off way far away by itself off to the side. Now look at this example here. On this one here, we have a box and whisker plot. Now on this one here, it shows the number of visitors to a gift shop in 1 month. Now box and whisker plots do not give us specific data values. They give, remember, what you get is you get your median, you know what the smallest and the largest number in the data set are, because those would be your extreme values, which in this case would be 10 and 90, but you really don't know what specific other numbers that were given here. So in this type of Semileaf plot, in this type of box plot or box and whisker plot, we also call it, you cannot identify any gaps because you don't know where the gaps are at. You can't tell where the peaks are at. And in this one, there's no clusters. And the reason why there's no clusters is look at these parts here. They're all basically equally spaced out. So if you look at, let me get here. So if you look at this chunk right here, that's about the same size as this chunk right here, which is the same size as this chunk, and about the same size as this chunk. Now, if you look closely, yeah, the right whisker, I think, is just a tiny bit longer, but overall, this is actually pretty symmetric. So then you're going to tell me first, is it symmetric? The distribution is symmetric since the left side of the data looks just like the right side, even though we said it was just a teeny tiny bit longer on that right whisker. There's obviously no outliers because on a box and whisker plot we would see that little asterisk star, and there's none here. And you really can't tell in this one if there's any gaps, peaks, or clusters. And really in stem and leaf, I keep saying stem and leaf plots, in box and whisker plots, you can't tell where the gaps are or the peaks are. But you can tell sometimes where clusters are, but we can't tell in this one. But there will be an example in the future screen where I'll point out where a cluster would be on a box plot. All right, so now it's your turn to give this a try. So you're going to look at this histogram and you're going to tell me, start with telling me if it's symmetric or not. And if it's symmetric, tell me why. If it is not symmetric, tell me why. And then go through each of those vocabulary words. Where are the clusters? Where are the gaps, the peaks, and the outliers? And if there aren't any, then go ahead and just tell me that there are no gaps or outliers. All right, so if you haven't paused the video yet, go ahead and pause it because I'm about to show the answers. All right, so the first thing I'm going to do is talk about whether the distribution is symmetric. It is definitely not symmetric because if you look at it, the left side of the data does not match or look exactly like the right side of the data. There is a cluster between the 0.01 seconds to 2 minutes and 30 seconds, to the 7 minutes and 30 seconds. So you've got a cluster, let me fix that better, over in this area where you have a lot of your data, so that's definitely your cluster there. The peak, which is the high point, is that first one. So here's our peak right here, and I indicated that with the time intervals, the duration, which would be 1 second to 2 minutes and 30 seconds. And then there are no gaps or outliers on this example. So you can see it's pretty straightforward. You just have to make sure you're covering each of the vocabulary words and putting it in your actual writing. Okay, so now, we've talked about throughout this past chapter, the chapter 11 and this chapter, about when to use or which measure is the most appropriate, whether you're going to use measures of center, which would mean like the mean, median, mode, or if you're going to use the measures of variation. So this explains it, I think, a lot better on this one. So you're going to first look to see if it's symmetric, all right? If your data is symmetric, then you're going to use the mean and mean absolute deviation. Okay, so those are the two there. If your data is not symmetric, this is where you're going to use your measures of variation, and that's where you're going to use your median and your interquartile range. Now remember, to find the interquartile range, you still have to find your quartile 1 and quartile 3. So that's the best and easiest way to know which one you're going to use. So remember, if it's symmetric, you're going to use mean and mean absolute deviation, and if it's not symmetric, you're going to use median and then the IQR. If there's ever an outlier, the distribution will not be symmetric, so therefore you need to find the median and the IQR. All right, so look at this one right here. So looking at the line plot, it shows the number of states visited by students in a class. So it asks us to choose the appropriate measure to describe the center and spread of distribution. And it does say to justify your response, which means you have to prove it by writing. Now, first of all, remember I said the first question we're going to ask is it symmetric? Nope, not even close. And if you'll notice here, this definitely looks like an outlier right there. So because of that, what I need to tell in my description is written right here. The data are not symmetric, and there is an outlier, which is the number 19. So therefore, we have to use the median and the IQR. So you're going to sit there and tell me that the median and the interquartile range are the appropriate measures to use. All right, so that's the first part. So when you're describing this, tell me whether or not it's symmetric, and then you have to sit there and tell me that you're going to be using the median and the IQR for the appropriate measure. The second part, to finish out your sentence describing, is you have to tell me what it is. So you're going to go through the process. The median would be 12. The first quartile is 11. Third quartile is 13. So therefore, the IQR would be 2. And in this case, it has to do with the number of states. So therefore, it would be 2 states. So be sure to make sure you put part of the title somewhere in one of your answers. Okay, so now it's your turn. So now on this one here, for part B, you're going to do the same thing that we've been doing. It says here, choose the appropriate measure to describe the center and spread of distribution. Justify your response based on the shape of the distribution. Then describe the center and the spread. Okay, remember that first question that I've asked you to look at. Is it symmetric? So if you kind of look at this, you can kind of tell it sort of really is. So look at the top of your page and see what you have to find in order to give me the measure of center for this one. All right, you guys, go ahead and pause your video now and make sure you get me all the information that is required. All right. So since the data distribution is symmetric, so if you look at it, both sides are the same, that means the mean and the mean absolute deviation are the best measure. The mean is 29, and the mean absolute deviation is 1.7 years. Okay, so now let me talk to you about when something is completely symmetric. This is a perfect symmetric line plot, which means exactly each side is the same. So the center obviously is going to be right here at the 29. All right, so that means your mean would have to be 29. So if you sat there and added up all those numbers, you probably got something around 500 something divided by 24, but you don't need to do that because it's the fact that it's completely symmetric, your mean is going to be right there in the middle, which is the 29. Okay, so that saves you a step there. Now remember, in order to find the mean absolute deviation, you have to figure out how many spots away each number is from the mean. So for example, the number 25 is 4 spots from the mean because you've got 26, 27, 28, and 29 to get from 25 to 29. And I went ahead and wrote underneath each of these, like how many spots each of these numbers were. So if you look what I did here, all right, so the 26, since I had 2 numbers that were 26, they were each 3 spots away from my mean, which was 29. The 27s were 2 spots away from the mean, which was 29. And my 28 was only 1 spot. Now, since I had 4 28s, that's why I wrote the ones 4 times. Now, on the other side, you're going to get the same set of numbers. So what you end up getting is 40. So remember, in order to find the mean absolute deviation, you've got to take your 40, divided by 24 because that's how many values that you had total, Okay, you have to count the total values, not the ones that we wrote down, because the ones in the 29 would be like 0 away, so those still count, remember? So then when I divided this, I ended up getting 1.6 with the repeating or bar notation over the 6 because it's a repeating decimal. Well, we can't use a repeating decimal in our information, so I went ahead and rounded it to 1.7 or 1 7/10, and that's how I got my mean absolute deviation. Okay, well, that's it for the lesson, you guys. I know we went through it kind of quickly, but a lot of this you've already learned from the previous chapter. So the new part is figuring out, are you going to use mean and mean absolute deviation, or are you going to use median and the interquartile range? So we did talk about what symmetry means. We talked about gaps and clusters and peaks and outliers again. So you want to make sure that you're using each of those each of that information. As you're doing questions 1 through 3, and on number 3 you have 2 parts, please be sure to refer back to the previous examples to make sure that you're answering these questions correctly and properly. All right, that's it for now. We will see you back in class.